So, let me start just now. So, hello everyone. We are having our webinar session by Women in Cloud Native, and we have Mohit here, who is from Denso Global Services, the head of engineering there. And Mohit comes with quite a lot of experience. I think Mohit has 20 plus years of experience in the industry, and he brings a variety of knowledge, and he's still a curious person. So, I think we'll have a lot to learn from him. Before we head into the session, I would want to give a short brief of what, as a community group, we are. So, this is Women in Cloud Native, and we try to learn new things together, and we try to make sure we keep learning, we keep engaging, we build this community. So, people here who have not yet joined our community group, you can find us on cloud native community groups, and we will just link it through the chat. You can have a look at it. Now, specifically delving into this event, as I would quote Mohit here saying that, how things work on my machine, but I don't know what is really happening inside. And that's where Mohit, as a deeply technically curious person, went into it, and he will be sharing all his learnings. And we'll hopefully have a lot of interesting demos to look at, as Mohit said. So, without taking a lot of time, I am going to also let Mohit take the stage. So, me and Sonali will be here at the background. If you have any questions, we'll have the chat open. Sonali, do we have a separate Q&A, or the chat itself will can be used for
Yeah,
this?
the we can post the questions in the chat and we'll take them at the end of the discussion or whenever Mohit is comfortable, like in the middle. If he wants, he can take,
Hmm.
otherwise at the end. Okay.
Yeah, awesome. Okay. Yes, we will be sharing the link for the community, Riddhi. We will try not to waste more time describing it, and we'll address that. And yes, Mohit, the stage is all yours. We are waiting to be amazed.
Thank you. Thank you once again. I hope I'm still reasonably audible. Yeah. So thank you once again for Women Tech community, specifically Sonali, Pranamita, and all the volunteers for having me here. Today our topic would be more on the Docker images. Most of us now, I assume that already know what Docker is. I'm not going to spend much time into that. But today's topic is more into why do we need Docker, or why do we need specifically Docker images. And for that, when we look for the answers, why we have to go back to the history of Linux and understand what was the challenge that they have faced while isolating their workloads. And one of the that challenge is basically I would say dependencies, which is uh, untrusted code, and how that untrusted code can basically damage the brand reputations. Uh, I guess we have good example of that yesterday only, where npm package called Axios gets compromised, and today all over the IT industry is basically trying to isolate their workloads, their servers, disconnect from server pools. So let me share my screen. Most of us we would be doing hands-on demos. So I assume if you would like to have Docker installed, that would be great. Otherwise, I will be sharing one link from Killer Coda. So let me just show you it. In case if you don't have Docker, just go to Killer Coda and you will find the playgrounds from Docker. You just need to sign in. I already signed in, so you will get at least 1 hour of Docker playground free, and that would be pretty much sufficient for us in case if you don't have Docker desktop installed or Docker installed on your machine. Just pick add or copy, and that's it. So uh, let me start the presentation. I hope this presentation is still visible in full screen mode. Yes.
Yes, Mohit.
Okay. So our topic is today is how the Docker images are kind of lie. I would say more of an abstraction. And as an engineer, we should be focusing on how we can break that abstraction in order to understand what lies beneath. So we'll go back to our journey back in chroot, which is one of the system call from Unix time, and we will see what challenge actually Docker images solve for us, so that it will be more appreciable when we are going to use in our projects, or even when we are using Kubernetes, because underneath Kubernetes we are managing pods which have nothing but the containers. So let's get started. This will be the agenda. What are the problem of application packaging? Then we will see chroot. We'll then straight away jump on hands-on demo for chroot. I have note down the commands. I will paste those syntax into the chat box as well. Uh, and then we will see what are the main challenges with chroot, and then how overlay file system, which is a layered file system from Linux, solve the challenge of chroot, and why Docker is relied on overlay file system. So basically, we are going to understand why behind the Docker images. I assume the audience have at least some hands-on experience with Docker. I don't expect too much, but at least they have, at some point of time, they have run Docker and Hello World. That is more than enough for us for today's demo. So why does the packaging even matter, right? We already know this classic developer nightmare, right? Where on dev machine we have, for example, a specific Python version which depending on specific library, let's say SSL, and then we actually configure some environment variables, and then we say, uh, I hope I'm still audible. There is
Yes, Mohit, you're
a
audible.
So then we say there is a dev environment, a local environment where we have everything works fine, right? And then when we actually ship that code to the production, then we can see that there are challenges like environment drift, where Python version can be a different. There might not be exactly same environment variables present, and then library version can be different, right? So dependency mismatch, environment drift, isolation, and basically repeatability. So reproducibility is there, is repeatability is not there. So these are the classical challenges that what we have seen before container era, right? And then there were some features of Linux kernel which basically helped us to isolate some of these problems. So this is what original idea from Linux kernel. Rather, this is a Unix system called back in 1972 or something of that. So yeah, 1979. And then this call basically allowed us to create a new root or a jailed process. So with the help of chroot, what you used to do is you can change your root uh, for the process you would like to. For example, when we boot Linux system, roots get mounted and then we interact with all the processes on that Linux system. But if we want to isolate our processes from the main root, then chroot was introduced. So the challenges with the chroot are, I would say, security, chroot escape. I am not going to cover this because it requires some kind of a coding background, specifically file IO. But what we're gonna do is we will at least see the process isolation part and manual dependency setup. So what we'll do is let's understand the problem. Rather, I have listened the song from Ek Villain, and there was one dialogue that जब तक हम किसी के हमदर्द नहीं बनते तब तक दर्द हमसे एंड हम दर्द से जुदा नहीं होते, राइट? सो इट्स बेसिकली वी नीड टू फील दैट पेन ऑफ व्हाई ch root is not enough. So with that, what I will do is I hope you are all logged into uh, this playground. You can follow me if you have already logged in. I hope my screen is still visible.
Yes, Mohit, at any point, if it is not, I will make
Okay.
sure to prompt you.
Sure. Yeah, thanks. Okay. So what we're gonna do is we're gonna run chroot command. I have already this documentation here. So uh, instead of running it directly on the Unix on Linux, what I will do, I will just paste it into the chat box for everyone's. So this is the command we need to run. This is more for from Docker perspective. So what this command will do is it will spin up the Docker container with the name as Docker host, and rm flag is basically when we done with this container, it will automatically reclaim all the memory and space that it has created for that. Privilege flag is required because we are going to call system call. Chroot is a system call, and for system call we will need sudo privileges. Ubuntu Jami have taken. You can take any Ubuntu version, doesn't matter. And since in this environment there is Jami is not present, so it will go and pull the Ubuntu image. Right. So right now we are inside the container. If you do PS, you can see just a one process which is bash. So we are inside the container and basically Docker container. Now what we are gonna do is we are basically going to run. We need to create a separate directory because we will gonna need new root, right? So whatever root we would like to configure for our process, we need to create a directory so that we can convert this directory into our new root. And then I will just paste it over here just to confirm that we have this new directory and ls, and I can see my new root here. So we have this directory created. What we'll do is we write some file inside it. Let's say my super secret. You can write anything inside that, doesn't matter what we are writing. My, so basically, it will create a new file called secret.txt inside the root that we have just created. So basically, we have just created folder, not a root, right? You can basically run all these demo in your Linux system as well, but as sudo and system calls are double-edged sword. In case something goes wrong, I don't want your system to be, not bootable since we are playing with root. That's the reason the approach I have chosen is to create Docker container, and inside that Docker container we can free to do whatever we would like to have. So now with this, what we need to do is we now go to chroot, which is our actual system call. What it will do is I will first explain the command. What chroot will do is it will change the root. So current root is our slash. It will change the root as mini root, and then we need to provide for which process you would like to do that, right? So before I executing this command, from the audience, is anybody following this? I would like to know their feedback. What is the outcome of this command for you? You can put into the chat box as well.
I am following, and right now I see that it says fail to run command bash, no such file or directory.
Right, and this is what the important point that what we need to understand why that
Okay.
command is fail, right? So the moment you do chroot, what and you provide this directory, what happened is your operating system has changed the root to this directory, and for that we I will just give you just diagrammatic representation of some concept. Okay, I need to just save this of my Git work. And for that, we need to understand more of an operating system from the process perspective. I hope this is visible, what I'm drawing, the blue rectangle and all.
Yes.
Yeah. So, what I actually mean by process is when you start operating system, I will do this is what your OS does. So this rectangle represents a RAM, and then whatever you do, let's say you run processes, and those processes is basically get some memory area into the RAM, right? So now the main important part here is that these processes, it can be any programs. For example, I'm conducting this session from browser or some kind of Zoom meeting. So basically, sharing the screen is itself need a device access. So all your programs are somehow dependent on the libraries from OS. So you have seen, in case if you have worked on any kind of web-based applications, and let's say this process is your HTTPD or Apache Tomcat, you would need some kind of ports from OS. You would need some kind of, I would say, network stack access, and all these access you get it from the OS, and that's what dependency is. The other thing is if this process is also created or this program is written into Java or .NET or Python, then these programs will not run on themselves. They will need some kind of runtime, and all these dependencies are basically configured or installed on the OS, right? Now, what happened right now is that we have basically, I will do one more, uh, and I will change this color, and I will basically send this to backward. Sorry, what I'll do, can maybe I will bring it to front. Yeah. So what happened is this process is now inside this jailed root, and since we have changed the root, we don't have the exact configuration. So if you have aware of the directory structure or file system from Linux, we have /bin, /lib, /dev, and so on and so forth, /etc, where all our configurations and dependencies basically reside. Unfortunately, since we have changed this root, the actual now after chroot, what has happened is it is become my new root is actual root over here. So this become actual root, and it doesn't have all these variable directories or environment path, and that's the reason it is failing that I don't find bash program inside this directory. So what should be the logical step is that we need to copy uh, the bash program from the actual root /bin bash to the new root. Is everybody got the problem? What problem actually happened because of chroot with this? Are we good so far? Why?
Yes, Mohit, I think it was
Yeah.
quite detailed, and
All right. Why
yeah,
bash
if
didn't
and
come?
people, if you have any doubts here, I'm sure you can post it on chat for Mohit to address it, or we bring it up.
Yeah. Sure. So that's the reason we it didn't find bash inside this my new directory, right? So as I said, since every process has some kind of dependency, it might be dependency on the runtime, on the libraries, or any kind of OS devices like network, hard disk, RAM, and all those things, right? So let's what we can do is right now let's copy the bash program from actual Ubuntu to our new root. Okay, so for that we need to create exactly similar structure that what we have used to in the Linux. So we need to create a bin directory. Why? Because in the root we have bin directory. So whatever we do while running processes on Linux operating system, the same thing we need to do with the this new root. Oh, sorry. I will also paste those commands into the chat box. I'm doing this, and then we need to copy. So for right now, I will just copy only bash because same thing we need to do for ls as well. But that's something we can look for homework for your own dash bin. We are, oh sorry, I didn't copy it. So c slash bin bash 2. I need this into my new root slash bin. Please don't make mistakes. I'm going to anyway copy all the commands for you because otherwise it will give an error. And unfortunately, we have only 50 minutes of time on the killer coda. So we need to copy this, right? And now what we'll do is we need to again run the our bash command. Uh, can anybody run this command again, chroot, and tell me the outcome?
Yeah, it's still the same error.
The same, right? And why is that? Because we have just copied the bash program, right? We didn't copy the dependencies,
Correct.
right? And so dependencies are of two types. I will not go into detail, but basically we can attach dependency to the executable directly, or we can embed it, dependencies in the executable. We call it as a static linking. This is quite a very much older concept, and most of our kernels are still rely on static linking. But all the modern programs nowadays are basically uh, work on dynamic linking. And now, since we need bash, we need to identify what are the different dependencies on bash. So what we can do is we need to run LDD command, which is uh, load dynamic dependencies, and then I would say slash bin, for which program I would like to tell, I would like to query what are the dynamic dependencies for this program. Ignore the text which doesn't have path, and then you will see these are the dependencies that we would need, right? Now, since copying this dependency will not help, what we need to do, we need to understand the path. So we need to again create a similar structure, folder structure in our container in order to ensure that these directories would be there, right? So again, what we need to do, we need to do mkdir slash my new root slash lib, because there is no lib directory. We have only created bin directory, right? So what I'll do, I will give these commands in the chat box.
Hey, Mohit, if you want, you can just give me that whole file, and as and when you execute, I can
Oh,
paste the commands there.
oh, that's good. Yeah, thanks. Yeah, it will be good.
Yeah, you can just
Yeah,
DM me.
yeah. There is one caveat
And
though.
and I think if you can just remove the screen in the bottom, I think you're getting a mirror there.
Is it this one, right?
Yes,
Okay, I thought.
sure. Thank you so much.
Okay, good, yeah. Right. So we have created lib directory, and then you can just follow. Yeah. So one caveat you can see is that here this command will not work because look at the architecture. So I have tried this demo on my MacBook, and MacBook is Apple Silicon because we are on M1 families. I'm on M5 right now, the latest processor, and Apple Silicon are ARM based. So there are two architectures in CPUs. One is 32-bit or 64-bit and ARM based. So basically desktop based processor and battery optimized processor. So this will not. So what we need to do is basically we need to check the path ls slash lib, and then we can see here this directory. So you need to change here as this entire path. This path as why? Because this is very much architecture specific. So we are on x86 architecture in the context of this killer coda machine, right? So what I'll do, I will create mkdir. Maybe you can follow me here, those who can. Mkdir, and this is for those who are doing it live on killer coda slash x86. Let me paste it. Uh, we need to create this directory inside slash lib. Yeah. Why? Because this is the exact path for root, and basically we are constructing the new root, which is my new root, right? So we need to also specify here my new root, my my new root. So this is what we are doing. Yeah. So now we have created this path in my new root. Now it's time to copy this entire uh, file. So what I'll do is going to copy this. So cp, we will copy this file. Where we need to copy? Inside slash my new root lib slash x86 gnu, this folder. So this is copied, and then similarly we need to copy libc.6. So again cp, and then we need to copy this guy. I know this is a lot of pain, but without pain there is no gain, right? So we will not able to understand the crux behind the Docker images. And then similarly we need to do is my new root, and this is inside lib and x86. We need to copy into this folder, right? And here there is a new folder, so we need to create mkdir slash my new root lib64, because this is again new folder. So look at the pain every time. This is just for one single bash process. What we need to do, we need to replicate all the paths of the host machine into the new jailed root that what we are trying to create. And then we need to copy this guy. So just do cp, and then I will paste, and this has to be go inside my new root lib64. That's it. So now we have copied almost all dependencies. Let me check. Yes, this is one, this is two, and this is three. Yeah. So now let's try our command, which is chroot, and let's see whether this time it works or not. Look at this. Now it is working perfectly fine. So we are in bash, which is the jailed bash. If you do these steps properly by what I do, maybe I will just copy all these steps. If you can do this now, certainly it's gonna help. Or you have created documentation based on my local machine, and that's
Hmm.
the reason the architecture would be different. I can literally show. So I have this terminal. Let me start a new tab, new window, and Docker run. Yeah, this is okay. Okay, it's already there. It's already running. So what I will do, I will just change the host name as Docker host 2. And if I show you library folder from my system, look at this. I'm not sure how much you can see. Uh, Look at this, arc 64. If I yeah, so this is basically ARM 64, because the MacBook is ARM based laptop, and that's the reason we had to change from arc 64 to x86 Linux GNU. Uh, does this work for anyone? Have we tried this?
Yes, it is working for me.
Great. So what we do now is let's try to print cat secret.txt. Let's try to do this because we have created this file earlier when we have created this. If you can see, we have created this file in our root. And look at this cat command not found. And why is that? Because we have just copied only dash related
Bash.
dependencies, right? Now, I'm not sure how much gravity of the problem you are understanding. Now, let's make it complicated or at the scale, right? Every application that we run on our Kubernetes workload or Docker workload, every application is run inside the container, right? If I say my new root, this my new root is for one container. So for one container, just running bash inside one container, we had to go this pain, right? Imagine if we need these basic commands, ls, cat. Even if you try to run ls command, it will not work over here. Why? Because we only copied bash and its dependencies, right? So if my new root is only one process or one container, and we need to go through such kind of pain. Imagine if I need to run multiple containers on single host, which is a very normal scenario, right? In Kubernetes, we have seen that Kubernetes deploy a lot of pods in one single node, worker node, right? So for every worker node, we need to for every worker node, for every pod, if we need to create a separate route. I hope you are understanding the challenge, right? That's the one challenge. The other part is that most of the processes will need bash in order to check the logs, in order to see the I would say dependencies, access the path, right? And for one pod, I need to copy bash, cat, ls basic commands, let's say 20 basic commands. So if I need to run 5 pods, it will be a duplicated efforts, which is we said do not repeat yourself, right? So not only just duplicated efforts, that pod will get a lot of size because we are just basically copy pasting the existing files into the new directory. And so we basically facing scalability issues, we are facing size issues as well, right? So these are the main pain points why chroot wasn't the likely choice for the isolated application. Are we good so far? We understand the pain, right?
Yes, Mohit, this is very insightful. It's getting more and more interesting.
Yeah. And let's do one more thing. Let's see process solution. So what we have did so far is nothing but the uh, file system level isolation. So we have basically separated ourselves from the root by creating new root. But let's create one more tab. Let's create one more tab here. Uh, and what we'll do is we will create one. We will first attach our. So we will attach the same container that we have run in the previous tab. Will quickly give you this command. So just open a new tab and you can run this command if you have exactly followed as is. So now we are in the same container. Look at the ID. We are in the okay. We are in the same container. Now what we'll do? We will run. My bad. We will run this tail command uh, in that container where we haven't done chroot, right? Remember, in this, if you are see bash, that means it's a chrooted container, and this is a normal container. So we will run tail command, and what this command will do is by making ampersand sign, this command will run indefinitely, and it will print the ID. So we have this ID, process ID is 41 on this container, right? So run this command. You need to run this in a second tab, the tail command, right? And now let's come back to the chrooted environment and let's kill this. So we'll just check process ID again. For me, it's 41. For you, it might be different. So I have killed it. Look at this. That process is now killed. So this entire process is now getting killed. And what it means is that there is only file system isolation. Even with that file system isolation, we have a lot of pain points in order to manually copy the dependencies. This is something what we have touched upon, and this is also we have just touched upon that. So these are the main pain points of having CH root. And uh, as the Linux kernel development proceed ahead, that's where we have seen the overlay file system. So when we say in Docker images, they are nothing but the magic of overlay file system. Now we know the file system in Linux, right? We have ext. It started from ext, then ext2, ext3, now ext4. These are the type of file system in Linux. And then we have seen logical volume manager, where we can have data from multiple hard disks as a single directory or single drive. In so this is basically a type of union file system. So the ext family is a physical file system, so that we can directly interact with that. But then over a period, as this microservices complexity grows, there was a need for virtual file system. So for any file system, in order to basically read a file from any file system, we basically need read, or basically open, read, write, and close. These are the four mandatory application functions we need from any file system, right? So the challenge was, when you boot on Linux system, you can mostly uh, only knows exe file system, because other file systems are not much worked or workable condition in Linux. But in terms of distributed environment, we can have a network of different systems, right? So for example, I have a network of Mac, Windows, and Linux. So though Linux will have ext file system, Mac and Windows will not have same file system. Maybe Windows will have ntfs file system, Mac have hfs, which is hierarchical file system. So how we can ensure that, let's create an abstraction where the type of file system doesn't matter, and that's where virtual file system excel. It actually brings an interface where it just give us a four abstract function: open, read, write, and close. So most of you are aware of CNI, container networking interface, right? So you have various providers. You have Flannel, you have Cilium, you have View. So why they are able to have, you can just plug and play any networking interface. And why? Because you have a standard as CNI. So similarly, virtual file system is a standard, which is a base for the union file system, and overlay file system is a type of union file system. And what overlay file system does, it basically give you a merge view. So for example, if you have four different directories as layer 1, layer 2, layer 3, layer 4, and you have some data inside it. Let's say it's better to do this as a practically as well. I have already command for this. So how our uh, this CH root pain point solved by overlay file system. So I will again copy paste all these Linux command. Now we can get outside of this Docker. We don't need Docker. We can straight away jump onto the Linux playground. Uh, Let me see. This tab is of no use, so we can go to this. We'll type exit from here. After exit, you can see that we are right now again into our container. So this is our container. We in container we have ch rooted and started bash. Now what we'll do, we'll fire command to create four directories. So this command will create, basically this will kind of a loop in shell scripting. I'm creating mkdir, L is layer 1 to 4. If you see ls, we have L1, L2, L3, L4. And then what we'll do, let's do one thing. We will write uh, some text. This is text from L1, and we will write this into L1 slash L1.txt. Just quickly cat this to ensure that it has created L1.txt file. Yes. Uh, and then what we'll do, let's create two files for two directories, L1 and L2. L2 slash L2. Okay, it's fast. Let's create file for every directory. This is L3, and we will create L3. This is L3. Did I miss? Oh, I have. Okay, I need to break it because I haven't put the quotation. And similarly, L4. So we have created 4 files and 4 directories, right? We also need 2 more directories, and I will explain it in a bit, since we have very little time for the session. So I'm creating 3 more directories: upper, merge, and work. And this is the magical command that what we gonna use. I will explain the command first, and then we'll fire. Okay. So what we are going to do is we are going to create a mount. So this is mount system call from Linux. We are going to create a mount. What type of mount? Overlay mount. What is the name of the mount? Overlay itself. You can give here none, whatever name you would like to have, just give it. And then what would be the structure of this mount? So there will be the lower directories, and here these lower directories are present as right to left. So L1 will be the lowest, L2 will be the second lowest, it will be the L3 will be the middle, and L4 will be the top, at the top. And then upper directory, work directory, and the final merged view of all these directories. Okay. Mm, I think I have work merged. What is the folder I have created? Just it should work. Wrong FS type, bad option. Let's see this. I didn't put slash here. Or let's do this slash. Strange. Are you also facing the same issue for this command?
Yes, I am just seeing how can we fix this.
Uh, the command is perfectly fine. Let me try this on here. Uh, Mount is correct. Hyper overlay, yes, this is also correct. Let me quickly Google this. Mount, overlay mount command. Overlay mount. Yeah, we have created these lower directories L1, L2, L4. We don't need sudo because we're already in the. It's perfectly fine. Work and dash not. Let's just do one thing. Uh, quickly. Clear this. Unless we have merged. Yeah, this should have worked. Let's say dot slash wrong FS type. I type. haven't don't do this. Change ls merge ms really merge. Let me try it by typing this work, and after work it's a space and merged.
Uh, yeah, I just
Oh,
ran a
okay.
quick search. It says something to do with gaps,
Let me
is
check
admin rights.
if there is a merged now. Sorry, what do you say?
It says if we exit and try to run again,
Okay.
because it is hitting the caps is admin rights, it does not have it.
Shouldn't be because we are already on route. Let me try this again in different sessions. Yeah. If I do ls here, okay, ls happen. Oh, where this is created then? Root at the, okay, we are already at the root. Let me try this. Uh, I will create the folders once again. Shouldn't take time. Maybe it's something ls. Yes, all directories are there, and then I need to create a per merge and work. Yes, all this good. And then I will just create two files for now. I will create file. Yes, this one. Into uh, screen, screen, and D is sufficient. Let's run the overlay command now.
Hmm.
Slash root wrong address type. File system type is overlay only. Let's do one thing. Now, see, any other name?
Mohit, maybe we can just head over to what was expected here.
Yeah.
Just
So
another classic case of
sure.
demos going
Yeah,
wrong.
sure. So basically, what it does is, I will go back to PPT. Sorry, that's somehow not working. It basically show this way, right? So we have layers in the Docker, right?
Hmm.
So your directories, all the directories that when you create a Docker file, uh, is there an example of Docker file? Yeah. So lower dir is basically your image from image, and then you basically also do some npm install, copy something. So that is become the second load directory. And finally, when you Docker run, that's where your upper directory, which is your copy on write system. So I wanted to map this with exactly this guy. Not sure why it's not working. So load directory is nothing but your read-only layers of Docker image. So basically, load directory is your Docker image in plain and simple word. When you
Hmm.
Docker run, that container is running and creating the data inside upper directory. And work directory is basically a magic where you see all these folder as one single folder called merged. So that is what magic does by this work directory. These have worked initially. Not sure if there is. Let me check the mount point over here. It is already mounted. Uh,
So, just I'll take a second, Mohit, since
Sure.
we are 5 minutes to time.
Yeah.
Uh, if you would want to close up real quick, and then we can take the rest offline.
Yeah. I mean, this was the last point that how
Mhm.
overlay file system solved issues. The other critical point in overlay file system, basically extension of overlay file system from Docker side is that Docker actually hashed all the images for you, and those big since images are hashed, we don't need to copy each time the images, right? So since they are hashed, you just need to download once, and you can run all the containers with just one single image. uh, yeah, I mean, this is sorry team, I mean, somehow I couldn't show you the overlay file system would have worked.
Yeah. Yeah, that was, I think it was an amazing 45 minutes. We got to walk through, I think, in all the high level chaos, we forget what is actually going on. We never look into the layers. So, yeah, thank you so much, Mohit, for walking us through that, giving us like a, time check that, you are doing very complicated things, but, this is what is happening and this is the value that is being brought. I personally did learn a lot. And to the audience, I would say you can always catch up with Mohit, I'm sure, on his LinkedIn, or you can check with him. We will take I mean, I we were planning to do a Q&A, but I think we can skip on that for today. And I would urge people to, if they need, they would love to go through the recording once we have it up. And I'm sure Mohit will be more than happy to connect with you over LinkedIn, or if you
Please,
have more questions,
yeah,
we can connect
yeah, sorry for
with
the
him as well.
last minute hassle, but yeah, hopefully it will work.
Yeah, I think as we navigate through multiple security issues, one issue is how, things are always the demo breaks. So I think everybody is able to relate to you here. Uh, yeah. On the closing note, I would say thank you so much, Mohit, for taking this effort to create this whole environment, to make it so simple yet so insightful. I I think another issue we as engineers, or as even the young engineers, faces, people never go through the fundamentals anymore. Since Kubernetes becoming the new Linux,
Yeah.
we have lost touch with Linux, and this was really insightful. Thank you so much for your time, Mohit, and we hope everyone had a great time.
Thank you.
Yeah, it was. I think it was great to learn. I think the interesting part was when you said, okay, you copied only one thing for Bash. Now imagine doing it for 20 other commands. Because I have been into system administration for almost 3 years from long back, and I know how much isolation matters for a container environment. And when you have to automate all this setup and then figure out a way to run it in a secure way, I think it was amazing to see. Thanks, Mohit, for doing this, and especially doing it in like a workshop manner. Like people can go and try the commands.
I
Good.
think in my time with this community, this is the first time we went beyond a slideshow, and to do it along with you, that was even more amazing. Thank
Thank
you so much, Mohit.
you. Yeah, it was really
All right.
pleasure to have into this session. Yeah, let's connect on LinkedIn. Happy to resolve the issues that we have faced today.
Awesome.
Yeah,
Uh,
I think folks who have joined, they can post their questions in CNCF Women also. And I think I'm sure Mohit is already there, so he can answer the questions there also. So, and
Yes,
yeah, once the recording is up, I think we'll be able to we'll be able to share it then. Yeah,
sure.
yeah, yeah. I'm sorry, I don't know my camera. My son, you can hear him already
it's
with all
Utpal.
the. So yeah,
Sure,
but thank you, Pranamata, for hosting this night. It was great, and thank you everyone who joined. We look forward to doing more such sessions with such great speakers.
sure, sure. Okay.
Thank you, Mike. Thank you, Pranamata. Yeah.
Bye all.
Amazing
Thank,
time. Thank you,
thank
everyone.
you.
Bye.
Yeah.